All right, we want to go over our unit review for the basics of Unit 5. Okay, actually, not the basics, kind of the enriched topics of Unit 5. And so this warm up and practice is going to do that for us. So let's take a look at this. So this first question is asking us information about these two histograms. So we want to talk about the qualities of them. So I can tell that they are symmetric. And so the mean and the medians are about the same, which looks to be at 140. Okay. I also can tell that this histogram on the left has less variability because the data is more closely clustered around the center. So it's going to have smaller standard deviations. Um, and it may even have a smaller IQR that I'm not positive of, but I do know that the average distance from the mean will be smaller. Because here we have larger values on the outside edges, that's more spread. So we'll have larger standard deviation, more variability. Okay, so what happens is they do not have the same variability. They both do not have gaps in clusters, just this second one does. Only one of the graphs is symmetric, and that's not true. They are both symmetric. Both sets have the same mean. So yes, it's at 140, it looks like, and the same range. So going from 100 up to 180. That's the closest to true. I feel uncomfortable saying that I know that that minimum is 100 and that maximum is 180. It's just somewhere in that bar. So I don't know the exact mean and range without knowing the actual data, but that looks like the closest answer because E says they both have the same variance. So if you remember, variance is the standard deviation squared. Well, this one has a larger standard deviation, so then it's going to have a larger variance. So that's definitely not true. All right, number two, if a data set includes two outliers, one at each end. So this is interesting. If we remove those, which of the following could happen? Which is a possibility? So if I remove these outliers, I know the standard deviation will get smaller. Now, I don't know that the mean will change because what if one of these numbers is 100 above the mean and this one is 100 below the mean? Then when I remove those, the mean stayed the same. So that's the key to this problem is understanding that that variability definitely changes, but the mean could change as well. But there is mathematically a way that it could stay the same, and that's what it's asking is which is a possible result. And so that's then what we have here. Both the mean and the median remain unchanged. That's a possibility. Okay, number three. The median score was 175. So I took this data set and I went ahead and I numbered it so I could find out where things were. So if there's 13 pieces of data, then that's going to put the median right here at number 7 because we're going to split the bottom 6 and the top 6. All right, so the median is somewhere between 80 and 90. So the median is not a score of 75. I know that. The median is the data piece number 7 between 80 and 90. How about this? If 90 is above an A, most of the students received an A. Most is more than 50%. So this is 5 students. That's not more than 50%. So that's not true. More students scored below a 70 than above a 90. Well, below a 70, there's 4 of them. Above a 90, there's 5 of them. So none of these statements are true. All of these statements are false. So that's why none of them are true. Okay. Next, which of the following measures is most usually given to describe the center and spread of a distribution such as this? Well, I can see it is skewed to the right. So if it's skewed, if you have skew, then you must choose to use median and IQR. Ooh, symmetry. Use standard deviation and mean. Okay, so now, next one, number 5. Consider the following back-to-back stem and leaf plot. So which of the following is a statement true? So what I did is I actually went and put the data on the left into my calculator and calculated the data. The 5-number summary, the mean, the standard. Okay, so I got all of that stuff. And I did that for the ones on the right. And I calculated all of those as well. Then I could answer my questions. Okay, so the range is the high minus the low. So 94 minus 48 is a range of 46. This one also had a range. 98 minus 52 is a range of 46 as well. So they had the same range. The variances are not the same because the variance is the standard deviation squared. The means are not the same, 68 to 79.8. The medians are not the same. This one's median is 67.5. That one's median is 83. The sample sizes are the same. That's what this N is. N is 22. Okay? They had the same number of pieces of data. So 1 and 5 were the answers. All right. So here we had the situation where the mean response was 18% and the median was 15. So the mean is greater than the median. If the mean is greater than the median, then you are skewed to the right. The data is skewed to the right. All right, so now we have these 5 box plots over here. And we want to then match up the histogram that goes with them. Now, what I want you to make sure that you do is turn your head correctly when you go to take a look at these box plots, okay? So turn your head when you look at these box plots so that your number line has the 0 on the left, okay? So I'm going to take a look at these ones. Let's see, I'm going to go this way for me is what works. So that I can see the 0 is on the left. So A is skewed to the left. D is skewed to the right, okay? B and C look symmetric. E, I think this looks a little longer, so I would say E's a little bit skewed to the right also. So that's what I would have done first, is identified their shape based on where they were. So then I can see this number 7 is skewed to the left. Well, the only one that is skewed to the left is box plot A. All right, next one here. Oh, this one's symmetric and centered around 30. So let's look at my symmetric ones. Oh, poo, look. Both B and C are symmetric and centered around 30. So that worries me. So now what? Well, let's see. Okay, so between B and C. All right, so I can tell B has more data closely clustered in the center, whereas C is interesting. If you look at it, it has almost the same amount of data or same amount of spread for every quartile. So since all of those quartiles have about the same spread, that would look more like something that is uniform because everything's happening about this. There's about the same amount of data that could be uniform uh, in each quartile. So I would say if it's looking like this, to me, another thing is it looks like 50% of the data is between 20 and 40. Well, what does this one show? Yeah, here it shows 20% of the data or 50% of the data is between 20 and 40. So that's why that would do that. Therefore, I go with box plot B. Here we have one where we definitely have the largest amount of data on these outside edges. And you remember huge amounts of data in the itty bitty little space on the box plot. So we would have the largest amount of data on, and is it symmetric? There, yes, so it's symmetric also. So I have the larger amounts of data in these smaller whiskers on the outside edges. Ooh, except for look at E, but E doesn't look perfectly symmetric. So again, I'm going to go with C, smaller amounts of data on these outside edges. All right, moving on. So here we go. Each score is increased by 25. Addition only affects the center, the mean. It does not affect the spread. So the mean will become 525. The standard deviation will not change. All right, number 11. But this is 25%. That is a multiplication component. That's multiplying by 1.25. So that affects mean and that affects spread. So that multiplication component increases both mean and spread. All right, here we go. Let's check out our answers here. We've got this box plot. Okay, so let's see what happens. So this is interesting. So we have this lower outlier, okay, and it's 5 below the median. This is an upper outlier, which is 8 above the median. So keep that in mind, that this is really kind of like skewed to the right. I've got this higher one. Otherwise, it's symmetric. Other than this outlier and that outlier, it's symmetric. So says while the high outlier is from a private college catering to the very rich, that lower outlier is a private university which gives full scholarships to all accepted students. So removing both outliers will affect what? Well, I can tell that so it's definitely going to affect the mean or the standard deviation, okay? But I guess it's just asking about mean and median. So removing an outlier from both edges will definitely not change the median. Those outliers, you're just knocking off one number on each end. The median's going to stay right there. But that mean will change because we're taking off something that's a little higher. This right here was pulling the mean up a little bit. So it was pulling it a little more up than this one was pulling it down. So if this is pulling it up more than the lower one is pulling it down, then removing those outliers will make that mean go back down a little bit. The median remains unchanged, and the mean will go back down a little bit because this upper outlier, being farther away, had pulled the mean up. So that's what happens when you remove it. All right, now we want to match the box plot to these histograms. So I kind of just did a little bit of identifying on these first. So identified their shape, a little slightly skewed to the right. It looks centered around 25. This one's symmetric, centered around 30. This one, I don't know what's going on here. It's a little skewed left, I guess, centered somewhere around 30 to 35. Here, skewed to the right, okay, maybe centered there a little bit, 25 to 30 or something. And then here's another symmetric one, centered at 30. So E and B are similar. I would have to say B is going to be is less varied. E has more data on the outside edge. So E is more varied than B. So that's my preliminary thoughts about this. Now I'm going to come on down here. So C is skewed left. So the only one that's closest to a skewed left is histogram C. So there's my matchup for that. Next, histogram D. Oh, this one is skewed to the right. Okay. Now, while this one may be kind of skewed to the right a little bit, it's just got a little bit extra right there on that right. I think D is more skewed to the right. D is centered around 30 or a little below 30. Okay, D is a little below 30. And then same with A. Oh, here's how I knew the difference. Okay, here it is. So do you see this right here? Remember, we have 25% of the data from 10 to 15. So that's a lot. That's 25% of the data from 10 to 15. That's got to be a high amount of frequency bar. So that's why that one goes with the histogram D. All right, E is symmetric. Okay, and so while B and E are symmetric, okay, I think that, see all these here? These have equal size, equal widths on their things, on their quartiles. So their quartiles are equal widths. And honestly, I think that this B is going to have more data, or it's going to be smaller in the middle, and not quite as equally spaced out. Histogram E looks like the histogram could have 25% of the data equally in all those quartiles, but B has definitely less data in those outer bars. So it would have longer whiskers. It has more data closely clustered in the center. This 50% is going to go from 25 to 35. Is that what this is doing? No. B has 50% from 25 to 35. Okay. E is more spread out. So there's what's happening there. Number 14, this is just totaling all of these up. So 10 times this, so you're multiplying all of those out, getting that sum, and then dividing by 150. All right, 15. Where is the median? Well, we were told it's 175 pieces of data. Well, if I do 175 divided in 2, so 175 divided in 2, that's going to be your 87.5. So we round that up. 88th piece of data is the median. So where is data piece number 88? Well, here's the first 80. So 1, 2, 3, 4, 5, 6, 7, 8. So right about there, data piece number 88 is the median. So the median is somewhere in there between 5 and 10. And the only option is B. And 16, which of these must be true? So here we have these items here. And so, of course, I can do my fences, or actually, I think this is going to be talking about quartiles again. So do you remember how 25% of the data is below Q1? 25% of the data is between Q1 and Q2. 25% of the data is between Q2 and Q3. And 25% of the data is above Q3. All right. At least half of the customers spent less than 44.27. So, see, this is a median. So at least half is this much and down, and at least half is this much and up. That's true, because that median is at that 50th percentile. So there you go. B says 75% spent between Q1 and Q3, and that's false. How much spends between Q1 and Q3? 50% of the data is what's in the box. C is the same thing. 75% spend less than 58.97, and the remaining 75%, oh, gotcha. So it says 25% below Q3. No. D says the mean is 44.27. No, that's not the mean, that's the median. And E says the majority of customers spend 44.27. We don't know. That's just the location of the 50th piece of data, or 50th percentile. All right, number 17, it is a transformation. So we're just going to take our data. It says the expected value is the mean. So that's 19.25. So the standard deviation is 5.76. And so the question says, what's the new standard deviation? Well, 5.76. Plug it into the formula. 5.76 Plug it in, but do not subtract the 100. Multiply it by 75, but do not subtract the 100 because spread is not affected by shifting 100. All right, so that leaves you with 432. And then here's our last one here. Are there outliers? Well, we need to do the fences. And so I guess they gave me a standard deviation. So I could have done the IQR rule or the standard deviation rule, but the mean and the median are about the same. So I guess I did the standard deviation rule. Okay. Whichever rule you did, whether you did the mean plus 2 standard deviations and mean minus 2 standard deviations, okay, or you did the quartile fences, Q1 or Q3 plus 1.5 IQRs, Q1 minus 1.5 IQRs. Okay, look at this minimum. This minimum is not below this lower fence, so no lower outlier. Not below this lower fence, so no lower outlier. All right, well, let's look at the max. The maximum is 187. That 187 is above the upper fence for the standard deviation and above this upper fence. So the max is above the upper fence. So there's at least one outlier, and it's an upper outlier. And I think that's it. The next problems that you're going to be doing, this is the semester test review, which I'll just put on I'll put the answer key to that on there. So if you are taking the semester exam, then there is that review will be there for you. All right, good luck to you on your Unit 5 test.